Welcome to Network Professionals, the Cisco Networking Academy, your perfect training and certification partner. We offer online and offline international certification courses like IT Essentials, Networking, Cybersecurity, Network Security, and Cloud Computing. Our today's topic is Introduction to Content Switching. Content switches, also sometimes called application switches, is a class of network device that is becoming increasingly common in medium to large-sized data centers and web-facing infrastructures. The devices we traditionally call switches work at layer 2 of the OSI model and simply direct incoming frames to the appropriate exit port based on their destination MAC address. Content switches, however, also inspect the contents of the data packet all the way from layer 4 right up to layer 7 and can be configured to do all sorts of clever things depending on what they find. Cisco's CSM, Content Switching Module, and ACE, Application Control Engine, module will slot into its 6500 series switches and 7600 series routers, and Cisco provides standalone appliances such as the ACE 4710. F5 Networks is another major contender with its big IP LTM, Local Traffic Manager, and GTM, Global Traffic Manager, range of appliances. In functional terms, what you get here is a dedicated computer running a real OS. The big IP LTMs run a variant of Linux, with added hardware to handle the packet manipulation and switching aspects. The content switching application, running on top of the OS and interacting with the hardware, provides both in-depth control and powerful traffic processing facilities. A content switch can do much more. Virtual servers. This is one of the most basic things you can do with these devices. On your content switch, you can define a virtual server which the switch will then offer to the outside world. This is more, though, than just a virtual IP address. You can specify the ports served, the protocols accepted, the sources allowed, and a whole heap of other parameters. And because it's your content switch the users are accessing now, you can take all this overhead away from your back-end servers and leave them to do what they do best, serve up data. Load balancing. Once our users have successfully accessed the virtual server, what then? Typically, you would define a resource pool of servers on your content switch and then define the members, individual servers, within it. Here you can address issues such as how you want the pool to share the work across the member servers, round robin or quietest first, and what should happen if things go wrong. For example, you could say that if there is fewer than 2 servers up, then the device should stop offering the virtual service to new clients until the situation improves. And you can set up monitors, Cisco calls them probes, so that the switch will check for application availability, again, not just simple pings, across its pool members and adjust itself accordingly. And all this will happen automatically while you sit back and sip your coffee. You also need to consider established sessions. If a user opens a new session and their initial request is handled by server 1, you need to make sure that all subsequent communications from that user also go to server 1 as opposed to servers 2 or 3 which have no record of the data the user has already entered. This is called persistence, and the content switch can handle that for you as well. Deep packet inspection. Content switches do all the above because they inspect the contents of incoming packets right up to layer 7. They know the protocol in use, for example, and can pull the username and password out of the data entered by the user and use those to grant or deny access. This ability unleashes the ultimate power of the device. You can inspect the whole of the packet including the data and basically have your switch do anything you want. What is scalability? What happens if you suddenly double your user base overnight and now need 6 back-end servers to handle the load instead of 3? No problem. Just add 3 more servers into the server pool on your content switch, plug them into your back-end network and they're ready to go. And remember, all you need here are simple application servers because all the clever stuff is being handled for them by the content switch. With an architecture like this, server power becomes a commodity you can add or remove at will. And it's also very easy to make application level changes across all your servers because it's all defined in the content switch. How might you see a content switch physically deployed? Well, these are switches, so you might well see one in the traditional, straight-through, arrangement, or since they are VLAN aware you might also see a content switch on a stick. You'll also often find them in resilient pairs or clusters offering various failover options to ensure high availability. And it's worth pointing out here that failover means just that. The session data and persistence information is constantly passed across to the standby so that if failover occurs even the in-flight sessions can be taken up and the end users won't even notice. Content switches go far beyond the connectivity and packet routing services offered by traditional layer 2 and 3 switches. By inspecting the whole packet right up to layer 7 including the end-user data, they can intelligently load balance traffic across multiple servers based on the availability of the content and the load on the servers. Monitor the health of each server and provide automatic failover by rerouting user sessions to the remaining devices in the server farm. Provide intelligent traffic management capabilities and differentiated services. Handle SSL termination and certificate management, user access control, quality of service and bandwidth management. Provide increased application resilience and improve scalability and flexibility. Allow content to be flexibly located and support virtual hosting.